Hi students, today we'll try to solve these three problems that I've already drawn. So the first problem is that there is a block of mass small m and there is a block of mass 2m on the table. The second is that there is a force F equal to 2mg acting, and this side there is a block of mass small m. And the third case is that there is a block of mass 2m and there is a block of mass small m. We have to find out the acceleration in these three situations. Now for this, you have to know that this is called an etude machine. So in case of an etude machine, what will happen is that there is an acceleration formula, and the acceleration formula is m2 minus m1 whole divided by m1 plus m2 into small g. Okay, so this is 2m and this is small m. So you put the data here. 2m minus small m is small m numerator and denominator is 3m. So if you cancel them, you get the answer as g by 3. So this is the acceleration of the first case. Now for the second case, many of you will be tempted that okay, this is F equal to 2mg and also here 2mg is acting. That means it will have the same acceleration. But remember, this is force and this is not a block. So you should not solve like this. The force will create tension here. The concept says that if there is no mass, that is what we are assuming, these are the ideal pulleys, so obviously it does not have any mass, so this tension will remain unchanged throughout the string. The force is 2mg, that means the tension is will also be 2mg, and the downward force is mg. So upward is 2mg, downward is mg. So what is the unbalanced force? It is 2mg minus mg, that is equal to mg. So you divide the unbalanced force by mass and you get the acceleration in the second situation as g. We'll come to the third situation. The third situation says that there is a block of mass 2m and small m. What is the acceleration? Again, there is a common mistake here that many students think that this is a lighter block and this is a heavier block. So lighter block cannot pull the heavier block, because that is what is our day-to-day life experiences. So this means the acceleration of both the blocks must be 0, right? But that is again wrong, because your day-to-day life idea is coming because of what? Because of friction being present in our real life, in day-to-day life. But here friction is not given. So what happens that this block of mass small m interacts with gravity, creates mg, there is a tension T, and here is a tension T. So you can see from the free body diagram, on the block of mass 2m, there is a tension acting, and this tension T is what? It is unbalanced, right? So this means the 2m block will obviously have an acceleration along I cap. So this means the 2m block will obviously move because there is no force to counterbalance it. So imagine that this chalk is hanging here and here is a real life aeroplane or a train on the table. The chalk or the electron or any small particle can even pull a big train, a real life aeroplane or any mass, whatever heavy it is, provided there is no friction. Okay, so let us try to solve them. So what is the unbalanced force here? This block is going to go down, so it is mg minus t is equal to m into a, and in this situation t is equal to 2ma. So put the value of t here, you do the side change, so mg is equal to 3ma, cancel the mass, and a is equal to g by 3. So in this situation, we also get the same acceleration as the previous one, the first one. So I hope you like this short discussion. Common mistake, block and force, even though they are equal in magnitude, don't relate them as same and then try to use the etude machine formula. And the lighter block and there is a heavier block, don't think that lighter block cannot pull a heavier block. It will pull. Obviously there is a possibility that it cannot pull provided friction is given. So if there is friction, we'll deal that kind of problem in future. Then in that situation, the 2m block or the block that is above the table will not move. I hope you really liked it. Thank you. We'll meet in the next video. Ta-da.